There's no question that the US military has been at the forefront of many of mankind's greatest technological achievements. Everyday things like duct tape, the internet, superglue, silly putty, GPS, microwaves, I mean the list goes on and on and on. But all of these were invented due in some part to US military efforts. We test our limits and we redefine the word possible with each discovery. But while our dreams might be big, the next frontier of cutting-edge science is actually rather small. Actually, it's so small. Smaller than a single atom. Who are you? I'm you. I'm your superposition. You know, your other state, the civilian side that spent 3 years studying physics. I'm here to help you host the show. Honestly, that sounds great. I've got duty in a little bit. Oh yeah, no problem, man. I got this. Just go, stand duty, serve our great country. Aye, aye. What a swell guy. And good looking, too. Where were we? Ah, yes. The quantum realm. There we can see how the Navy is advancing the science of quantum information systems to develop technologies that were once thought to be impossible. We'll learn how these impossible technologies could be used to save Americans billions of dollars, as well as set us up to win the 21st century great power competition. Join me as we look into the world of a quantum Navy. Now, in order to wrap our heads around quantum technologies, we should probably try to understand just a little bit about the origins of quantum science.
This sum expresses the laws of motion that apply to macroscopic particles. To fit the observed behavior of microscopic particles, like electrons and protons, the laws must be modified somewhat. As modified, these laws are called quantum mechanics.
Okay, let's pause. This topic can get really confusing very fast. We should probably just speak to an expert.
So, my name is Tom Reinecke. I can tell you a little bit about the origin of quantum information science and technology. Quantum mechanics revolutionized science around the world during the 1920s.
The mathematics of quantum mechanics are quite complex, but we don't need to consider the details of the calculation.
Oh, thank you.
Our interest is in the results that quantum mechanics gives.
It built what we now know as modern physics. For example, things like transistors were developed, integrated circuits, computers.
These successes prove the usefulness of the quantum mechanical view of the atom.
So this new science changed the way we perceive the world. Got it. But what are some of the most important things that we should know from these scientific discoveries in the 1920s?
Now, there are a couple of subtle properties that arose during that time. One is called superposition. Superposition says that matter at the atomic level can exist in two states simultaneously, or as the story goes, Schrödinger's cat can be both dead and alive at the same time.
You heard him. We're not talking about some undead zombie cat. Schrödinger's cat is alive, and it's dead. But which one is it?
Well, this is a question that quantum mechanics does not answer explicitly. Quantum mechanics gives the results only in terms of probability.
This combination of existing in two states is called a quantum bit, or a qubit, and is a central part of quantum technologies. The other idea is entanglement. Entanglement is a purely quantum mechanical effect. It's a force which can couple things like qubits over distances. That's all I have to say on that point.
Well, all right then. Join us next time as we visit the Navy laboratory that has been building upon the foundation of this incredible field of science to create technologies that were once thought impossible.